Okay, so these are just some different scenarios that you might see when coming across solving equations. The first one being clearing fractions. Now the thing about clearing fractions is you don't have to do it. A lot of people like to clear fractions because they don't like adding and subtracting and multiplying and dividing fractions. A lot of times it's hard to work with because you have to have common denominators. Adding and subtracting is difficult. So clearing fractions is an option to get rid of all the fractions in the problem and then just solve it like a normal equation. Not to say that fractions aren't normal, but again, I realize they are a little more difficult to work with. So if you're clearing fractions, you want to clear fractions by multiplying the entire equation So clear fractions by multiplying the entire equation. Okay. The entire equation meaning every single term, even if it's not a fraction. So you multiply the entire equation by the least common multiple. By the least common multiple of all the denominators. Okay. Now, least common multiple, it's often abbreviated LCM. So the least common multiple of all the denominators, all the bottoms of the fractions. Okay. What is the least common multiple? The least common multiple, if you remember from middle school probably, is the smallest value that all the denominators go into. Okay, so it's the smallest number that all the denominators go into. Now, one thing about clearing fractions, or one thing, it's not about clearing fractions, but it's about equations that have a lot of fractions. If your equation has a lot of fractions, whether they're coefficients or constants, you're more likely to get a fractional answer. So if you're doing these and you get a number over a weird number, some weird fraction, that's okay, because you're more likely to do it when you're dealing with fractional numbers. Okay, so let's look at this first example. We got 1/4 x minus 2/3 equals 1/2. So if you look at this, it's set up like it's just a normal two-step equation. Okay, and you could treat it like a normal two-step equation. And this one, you're probably looking at it and you're like, oh, I would just add 2/3 and divide by 1/4. Okay, if you want to do that, that's fine. Okay, now adding 2/3 to 1/2, you're going to have to get common denominators. And then dividing by 1/4, you're going to have to multiply by the reciprocal. It's not difficult. It's things you know how to do. You know how to deal with fractions. You've done this before in previous math classes. But again, it's not everyone's favorite to add and subtract fractions together. So let's try this by clearing fractions. What we need first is we need the least common multiple of all our denominators. So our denominators are 4, 3, and 2. So we're looking for the least common multiple of 2, 3, and 4. Well, a hint about least common multiples is it's never going to be smaller than the biggest number. So our biggest number here is 4, so it's not going to be smaller than 4. Okay? So one way to do it is you just check for multiples of 4. For example, 4. 4 is the first multiple of 4. The problem is 3 doesn't go into 4. Okay, so you go to the next one, 8. 2 goes into 8, but 3 doesn't go into 8. So go to the next multiple of 4, which is 12. 2 goes into 12. 3 goes into 12, obviously 4 goes into 12. So 12 is the least common multiple. Okay. So we're going to multiply the entire equation by 12. Okay. So I like to just put brackets around the entire thing and then times 12 on the outside. Now when you're multiplying a fraction by a whole number, and again, multiplying everything by 12 doesn't seem like it's going to make it easier, but trust us, it will. When you're multiplying a fraction by a whole number, you only multiply the top number. Okay, so we're going to multiply 1 by 12. So 1/4 times 12 will give us 12 on top, and then you leave the bottom the same. Okay. Then the next term, negative 2/3, you're going to multiply the top number by 12 and leave the bottom number the same. Again, keep the sign the same too. Negative 2 times 12 is negative 24, so minus 24 over 3. And then the last one, multiply 1 times 12, leave the bottom the same. It should be 12 over 2. Now again, this doesn't look easier, but it is, because if you pick the correct least common multiple, all of these values are going to simplify into whole numbers. So if you look at these, really what we have is 12 over 4. 12 divided by 4. Remember, fractions are just division. So 12 over 4 is just 3x. Okay. 24 over 3. 24 divided by 3 is 8. And 12 over 2, 12 divided by 2 is 6. So again, if you do this correctly, every single time it's going to, all these fractions will simplify to whole numbers. Okay. So now this is a lot easier to work with. It's still a two-step equation, but it's easier to do 6 plus 8 and then divide by 3 than it is to do 1/2 plus 2/3 divided by 1/4. So we'll just do the two-step equation here. Again, you guys should be able to identify this just by looking at it. It's going to be an add 8 and then divide by 3. So we'll add 8 to both sides. 8 crosses out on the left, leaves us with 3x equals 14. And then divide by 3. And it gives you the answer of x equals 14/3. Okay. And we're just going to leave our answers as fractions. No need to convert it to a decimal, no need to convert it to a mixed number. Just leave it 14/3. Alright, the second problem, same thing. Okay, this one's a little more work. Okay, on this one you'd have to get all the x's on the same side, which would involve doing 4/3 minus 4/5, and then you'll have add 2 to 7/2. Alright, instead let's just clear fractions. We're looking for a least common multiple, okay, of all of our denominators. Our denominators being 5, or 3, 5, and 2. Okay. So find the smallest value that 3, 5, and 2 all go into. Okay. Well, again, you could start by just doing multiples of 5. Okay. 5 doesn't work. Okay. Only even numbers are going to work because of the 2. So 10, 3 doesn't go into 10. 20, 3 doesn't go into 20. 30. 3 goes into 30, 5 goes into 30, 2 goes into 30. So our least common multiple for this one is 30. So we're going to multiply everything by 30. So multiply each term by 30. Leave the top number the same. Or multiply the top number by 30, leaves the bottom number the same. So 30 times 4 is 120 over 3. Now a lot of people forget this next one. You're multiplying every single term. That includes the 2. Even though it's not a fraction. If you're multiplying an entire equation, you have to multiply every term by that equation. You can't leave one out. So we do have to multiply the 2 by 30. 2 times 30 is 60. Okay. And then the rest of these, multiply the top number by 30. So 4 times 30 again is 120. This time it's over 5. Okay, x, and now all the x's and the signs and the equal signs, they all stay the same. We're just changing the numbers, the coefficients. And then 7 times 30 is 210 over 2. Now again, if this was done correctly, if we picked the least common multiple, all of these fractions are going to simplify. Okay. So top number divided by bottom number. 120 divided by 3 is 40. Okay, so 40x minus 60, okay, that doesn't change, equals 120 divided by 5 is 24. And then 210 divided by 2 is 105. So now we have all whole numbers. Now it's going to be a little easier to work with just whole numbers. Just go through, get all your variables on the left side. So I'm going to need to subtract this 24x over. I'm going to need to subtract, or not subtract, but add 60 because it's already minus 60. So we'll add 60 to the right side. The 60s go away, the 24s go away. On the left side, all we're left with are the x's. 40x minus 24x is 16x. On the right side, negative 105 plus 60 is negative 45. And now it's just a one-step equation. Divide by 16. And that is just going to be our answer. X equals negative 45 over 16. Okay. You should check if you could simplify it. This one you can't simplify that fraction, but always check to make sure it's in simplest form, and that's your answer. So that's clearing fractions. That's getting rid of fractional coefficients and fractional constants. The last scenario we're going to talk about also deals with fractions, but this time it's what happens when your variable is in the denominator of a fraction. Okay. So on this one we have two fractions set equal to each other. When two fractions are set equal to each other, it's a proportional equation. Okay, so we know 2/3 is equal to 5 over x plus 4. We don't know what the x is. So when you always want to get rid of your grouping symbols, and remember that a fraction is a grouping symbol. Okay, so we want to get rid of our fractions. How we're going to do that is we're going to use cross multiplication. We're going to cross multiply. When you cross multiply, you're taking the top of one of the fractions and you're multiplying it by the bottom of the other fraction. Okay. So on this one, we're going to take 2 and multiply it by x plus 4. X plus 4 grouped together because it's a grouping symbol. So we're going to do 2 times the quantity x plus 4. And in cross multiplication, that's going to be set equal to the last cross multiplication, which is going to be the bottom of the first times the top of the second, which is 3 times 5. Okay. Those are equal. Those are always going to be equal. Okay, but now we don't have a fraction anymore. Okay, our variable is not in the denominator. It's up in the normal line. So now we're just simplify and solve. On this one, we're going to have to distribute 2 times x, 2 times 4. So give us 2x plus 8. And on the right side, you have 3 times 5. You just simplify that. 3 times 5 is 15. Okay. Two-step equation now. Again, these two-step equations are going to pop up everywhere. The two steps on this, just our visual two steps, it's going to be subtract 8 and then divide by 2. Alright, so subtract 8 from both sides. Left side goes away. And we're left with 2x equals 7. Divide both sides by 2. You get x equals 7 halves. Okay. 7 over 2. Again, just leave it as a fraction. Don't make it a mixed number. Don't make it a decimal, even though this is a nice decimal. Okay, what if there's more than one variable in our fraction? Okay, we're going to do the same thing. So this one we have x over x plus 5 equals 8 over 13. Well, we have two occurrences of x, which just means we're going to have more steps after we do the cross multiplication, which is fine. But we're going to deal with it the same way. We're going to take the top of x and multiply it by the bottom. So that's going to be x times 13 equals the bottom. Remember, the bottom is grouped together. The entire bottom times the top. That's going to be x plus 5 times 8. All right, simplify. On the left side, x times 13 is 13x. On the right side, you're going to have to distribute. Okay, remember, you could distribute backwards. It doesn't matter where the coefficient is. It doesn't matter if it's in front or behind. You can distribute backwards through the parentheses. So we're going to do x times 8, which is 8x, and then 5 times 8, which is 40. All right, now just solve for x. 40 is a constant. It's already on the right side. So what I'm going to do is I'm going to move the 8x from the right to the left. On the right side, it goes away. On the left side, we have 13x minus 5x. 13x minus 5x is 5x. Nope. 13x minus 8x is what we have, and it equals 5x. Getting ahead of myself. And then 40 is on the right side. Okay. One step from here. 5 times x equals 40. So divide both sides by 5. X equals 8. That's our answer. Alright, so those are two different scenarios that you'll see. They both kind of involve fractions. One's when you have a variable in the denominator or the numerator of a fraction. The other one's if your coefficients and constants are fractions. As far as these go, clearing fractions I would only do if you had like a lot of fractions with a lot of different denominators. If you have fractions with the same denominators, you could just add and subtract like normal. When you have a proportion like this, you always want to cross multiply. But again, when you're doing clearing fractions, I would only do it if you have a lot of different denominators that are going to be difficult to work with. Alright, so there's a couple more special cases we're going to deal with in the next live class, and that's it.